Hey Logan, welcome to another installment of Math from Your Couch. Today we're going to switch gears and we're going to set aside quadratics for just a little bit, and I want to talk about this other type of problem. They're called square root equations. So square root equations are they're just equations like normal, except they're going to have this added thing to them. They're going to be equations where the variable is inside the square root, inside the radical. All right, so what we want to do is we want to take a look at what these types of equations look like, and here are a couple of examples of what you can expect. You'll notice that in all three of the examples, square root of x minus 6, the x is inside the square root sign. The square root of x minus 7 is equal to 5. The square root is on top of the x again, but also with the negative 7. And then 3 square root x minus 5 is equal to 13, where once again the x is inside the square root. So what we want to do is, before we get into what we want to do, these are what the problems are going to look like. They're going to have variables where the radical or the square root is on top of those variables, or the variable is inside of the square root. Those are some of the words or the ways you'll hear it talked about. So the first thing we want to do is we want to look at our strategies or our techniques. So what I'm going to do is very similar to quadratics or squared equations. What I want to suggest is that we isolate, okay? So we're going to isolate the square roots. That means get the square root by itself. Then after you isolate the square root, what we can do is we can cancel the square root by using its inverse operation, which is called the square, okay? So we're going to use the inverse operation, the square. To get rid of a square root, we're going to square it. And let's take a look at examples. Here's our first example, the one from our example set in green. We have the square root of x is equal to 6. So notice that the square root is already isolated. So we want to isolate the square root. The square root is by itself, essentially. Next, you're going to cancel the square roots with the square. So we have the square root of x is equal to 6. Now to cancel the square, what you want to do is you want to use cancel the square root, you want to use a square. So I'm going to take the entire side and I am going to square it. If I do this, if I square the left side, I must also square the right side. So I'm going to square both sides of the equation. Now, from the quadratics, you'll remember that squares and square roots cancel each other out. Sometimes teachers will do this. They'll cancel out the squares like that. I'm not that type of person, so I'm just going to leave it like that and write down that the square root of x squared is just x. So we have x equals, and then 6 to the power of 2 is 36. And that right there is our first example. Remember, isolate the square root, then cancel the square root using a square. Let's take a look at our second example. Now, in our second example, we don't have just the x inside the square root, we have the x minus 7. So we have to deal with that. So the first thing we want to do is isolate the square root. So the square root is by itself. There's nothing else there. Second, we want to cancel it. So we're going to take the square root of x minus 7, and we are going to figure out how to cancel it. Remember, the square root will cancel with the square. So I'm going to put a square on top. Now, if I square the left side, I have to square the right side. The square and the square root cancel, leaving us with just the x minus 7 is equal to, and since there's no square root to cancel, it has to actually square it, which will give us 25. 5 times 5 is 25. And now this is a traditional equation, a linear equation. All we're going to do is add the 7 to both sides to isolate the x now, isolate the variable, and we have x equals 32. And this right here is our second example. All right, taking a look at example number 3. What we have here is the 3 square root of x minus 5 is equal to 13. Now, this is the first example we're going to encounter where the square root is not isolated. That means it's not by itself. So we have to get rid of all those things that are not under the square root first. The first thing I'm going to do is I'm going to add 5 to both sides. So I'm going to add 5 to the left, and I'm going to add 5 to the right. Now, what this will do is this 5 and negative 5 will cancel, and that'll leave me with 3 to the square root of x is equal to 18. Now, remember, my job is to isolate the square root. Now, the square root still has stuff that's not inside of it on that side, so I have to get rid of it. So I want to get rid of this 3. Now, the 3 is being multiplied to the square root of x, so the inverse operation, the opposite of that, would be division. So I'm going to divide by 3 because that'll cancel it out nicely. But if you divide the left side by 3, you're going to also have to divide the right side by 3 to keep it equal. Now that you have the square root of x is equal to 6, the square root has now been isolated. To get the x by itself, we're going to square both sides. So I'm going to say the square root of x is equal to 6, and I'm just going to square the left side to cancel it, and I'll square the right side to balance it out. The result is that x is equal to 36. And we have our answer to our third and final example. All right, if you have any questions, hit me up on Google Classroom, or you can email me. I hope to talk to you guys really soon. Have a great day.